but the visuals were entirely in XAML. And this XAML clock, this XAML file, had 12 hourly tick marks around the clock, using 12 pieces of a virtually identical markup, except for the rotation angle. Now, to me, the loop is one of the most basic constructs in procedural programming language. And to deliberately forgo the use of a loop and instead use markup for 12 almost identical visual objects seemed to me a betrayal of everything that we programmers believe about our avocation and the fundamental primacy of code. Is what I'm saying familiar to anybody? All right. Anyway, as I started using XAML, though, I became more intrigued. I liked the way that I could see the hierarchy of a visual tree right on the page. And although everything you could do in XAML you could also do in code, sometimes the equivalent code was decidedly clumsier than the XAML. What's more, the clever developers at Microsoft had built features into XAML that compensated for the inherent limitations of markup. But also, simply because markup is inherently limited, it became a challenge for me to do things in XAML that were not so easy to do in XAML. It sparked my creativity. Does this resonate with anybody? Developers and engineers are, I think, wired a little differently from most people. We get a new tool and we think, I wonder what I can do with this tool in the absence of all other tools. And if the only tool I have is XAML, what do the problems look like? In short, what would it be like to live on planet XAML? Suddenly, it didn't matter to me if something was useful or not. If I could do it entirely in XAML, it was very, very cool. So you remember that repetitive markup I saw for the tick marks of the analog clock. I figured out how to make tick marks on an analog clock using a circle styled with a dotted line. And I did an analog clock entirely in XAML, using graphics transforms for performing arithmetic on hours and minutes and seconds. I proudly posted it on my website. One day soon after that, Tim Sneath at Microsoft wrote a blog entry challenging people to create the most impressive demo they could using just one line of XAML. Before midnight on that day, I had posted 6 single-element XAML files on my blog. And I'm not trying to brag here. I'm only trying to describe my sickness. And then, when I started working with WPF 3D, where you can do animated 3D scenes entirely in XAML, the sickness only became much worse. And eventually, I had to calm down, and I had to learn a few lessons. Moderation is a difficult concept for me, but it turns out to work better than snobbery or mania. Living on planet XAML might be fun for a little while, but an all-XAML diet will eventually cause your teeth to fall out. And it turns out that XAML is great for creating and visualizing the hierarchical visual layout of your page, way better than the equivalent C# code. And there's a good reason for that. C# is mostly a procedural programming language. XAML is a declarative language. The C# code shows the process of building the UI, while the XAML shows the finished UI itself. And so it's much clearer. Now, along with crafting the layout of the UI elements, XAML is also good for describing basic interactions between these elements, including animations. Some of this involves data binding. Data binding syntax is much cleaner in XAML than in code. So XAML is for the UI. The real infrastructure of the application remains in code. And very often, what you do in XAML must be supported by code. To me, the theme of this talk is how to identify what code you need to support what you want to do in XAML. We want to hit the sweet spot between code and markup. And finally, let us never forget that we're here to write applications rather than just having fun. The fun should be a result of writing the application. And if we don't have as much fun as we would like, well, that's why we get paid. So if we want to express the relationship of code and XAML in terms of 18th century German idealist philosophy, sometimes two opposite or opposing concepts, when taken together, become something bigger and better. Or, I believe that this is the first time I've ever used the word awesome in public, or perhaps at all, but there it is. So what I'd like to do in this talk is give you a whirlwind tour of what I consider to be the crux of XAML syntax, as well as a little XAML philosophy. And the theme here is the balance of code and markup. Now, the reason we care about XAML at a Xamarin Evolve conference is because XAML is supported by Xamarin Forms. Here is a simple XAML file, as it might appear in a Xamarin Forms application. And I'll very briefly give you a brief guide. A XAML file is XML, and hence consists of XML elements arranged in a parent-child hierarchy and attributes of these elements. There are always at least two XML namespace specifications in a XAML file. The first is for elements with no prefix. Those elements are part of Xamarin Forms, as the fake URI indicates. The second, for an X prefix, is for elements and attributes that are intrinsic to all implementations of XAML. That X prefix is used right away for an attribute in the root element named class. What this attribute means is that the XAML syntax page class in the XAML master namespace derives from content page, the root element. This XAML file effectively defines a new class named XAML syntax page. On this page, you see elements named content page, stack layout, label, button, slider. Those are all Xamarin Forms classes. Classes in C# become elements in XAML. And in the context of XAML, these are called object elements. This XAML file also has a bunch of attributes set on these elements. These attributes are all properties of the respective classes. Hence, they are called property attributes. Doing a Marco Rubio here. OK. Now, the reason for this terminology is because we also need a name for these things. This is the syntax you use in XAML when you need to set something to a property, and the thing you need to set to that property is not expressible as a simple string. In this particular case, we need to set the stack layout to the content property of content page. We need to add the label, button, and slider to the children collection of stack layout. And the way to do that is by making an element tag that consists of the class name and a property name separated by a dot. And hence, these are called property elements. And they are an extremely important part of XAML syntax. Even after you've been doing XAML for a while, I guarantee you'll come across a need to set some large piece of markup to the property of another element, and you think, how do I do this? And the answer is, use a property element. Now, the first time I saw this class.property syntax, my reaction was, is this legal XML? Absolutely. The period has no special meaning in XML. To any XML parser, these things are normal XML elements. So in summary, every XML element in a XAML file is backed by code in the form of a class or structure. Almost every attribute is backed by code in the form of a property or event. There are exceptions, but there aren't very many. As the name suggests, XAML is extensible. You can put your own classes in a XAML file. Now, it turns out in this particular case that the content page.content tags and the stack layout.children tags are not required. Every class is allowed to have one property that is specified as a content property. This is done with a content property attribute on the class. And the content property for content page is content. The content property for stack layout is children. So those tags can simply disappear. Let's take a look at what this page looks like when it's running. I have a demo program running on Android and Windows Phone emulators. And here is that page in Android, and here it is on Windows Phone. The slider like so, and click the button. And that's a native UI on Android and Windows Phone. So you saw how property elements appear in a XAML file with a class.property syntax. There's only one other place you see class.property, and that's as an attribute. Here's a label that is a child of a grid, and this grid implicitly has 2 rows because the label is in row 1, and the rows are 0-based. Again, you see this class.property syntax. In this context, this is called an attached property. The row property is defined by the grid class. And the color structure also has a type converter attribute named color type converter that converts these strings to color values. This color type converter can handle color names, such as blue, that correspond to colors defined in the color structure, or RGB values in hexadecimal. The font size property is of type double, but you can also specify small, medium, or large. And the font size property itself has a type converter attribute referencing font size converter, which performs this conversion. Now, earlier I said that part of my skepticism about XAML is based on my love of strongly typed programming languages. To me, these type converters are what makes XAML itself a strongly typed markup language. I realize this is a bold statement to make, but it is based on over a decade of experience with XAML. Write that down. XAML may look like a bunch of strings, but it's not. So we see already how XAML is supported by an infrastructure of code. And what's more, you can write your own type converters for your own custom properties of your own custom classes. The file is not, as I mentioned, not just a hierarchy of elements. It's a class definition. According to the XClass attribute in this particular XAML file, the more XAML syntax page class in the XAML master namespace derives from content page, which is the root element. Every XAML file has a companion C# file called a code behind file. And when we look at this code behind file, it says exactly the same thing. It's the XAML master namespace, the more XAML syntax page class deriving from content page. Notice also it's a partial class definition. What happens is that during the build, another partial class is generated from the XAML file that contains an implementation of a method named initialize component that loads into XAML, either the text file or a compiled file at runtime, and instantiates all the elements in the XAML file and sets them to this content page. Now, in the remainder of this talk, I want to explore 3 general questions. How do we harmonize code and markup so that we don't have a lot of repetitive markup? And how do we support XAML with reusable code? Let's go back to the phone emulators. I have a program here called rotated text, which displays, the word XAML, displays the word evolve, 16 of them rotated around in a circle. Now, such a page can be realized entirely in XAML. Let's go into Visual Studio, see how that's done. Rotated text verbose. OK, and here's the markup. And this is precisely the type of nonsense I was talking about earlier. Here are 16 almost identical chunks of markup that differ only by a rotation angle. This is horrible. It's a major hassle if you want to change something, and it really offends us. Obviously, it would make more sense in code to do it in a for loop. However, XAML includes several other features that compensate for the deficiency of not having loops. One of these features is called style. Now, a style is basically a collection of property settings. You can create a style object in code, but almost always styles are created in XAML, and they're shared among visual elements. Every visual element has a property named style that can be set to a style object. And here's how it looks. Rotated text style page. There we go. There is the style at the top. Now, to store objects such as styles, Xamarin Forms includes a facility called a resource dictionary. Every visual element defines a resources property that you can set to a resource dictionary object to store shared objects. The style is a collection of setter objects, each of which assigns a value to a property, even attached property. And notice that it's enclosed in curly braces. This is known as a XAML markup extension, which is a facility to indicate that a property is being set indirectly. It's not being set to a value that derives from some string, or it's not a style object directly, but it's indirectly via another process, in this case, a dictionary access. And although this is called a XAML markup extension, it is not any kind of extensions to XML. To XML, this is a plain old attribute setting. Now, the static part of the name static resource is to distinguish it from dynamic resource, which is very similar. But if the dictionary entry changes, the property set to that dictionary entry will also change. In this particular case, we can simplify the markup even more. We can eliminate the and a dictionary key is generated automatically. It becomes what's called an implicit style. You can then remove the static resource markup extension, and the style is applied automatically if the element matches the style target type. And now, this markup, I think, has become much less onerous. Yes, there are still 16 explicit label elements here. And obviously, in code, you would do this in a loop. But you'll have to admit that what we have gained is a considerable amount of visual clarity to how this page is structured. It's easy to see at the top the property settings that the labels have in common, and also to see each unique property setting. Let's say you also want to set unique colors for these labels, and you want to use the colors of the rainbow going around in a circle. Now, the colors of the rainbow are easiest to specify if you're specifying colors with the hue, saturation, and luminosity model rather than red, green, and blue, because all you need to set is various values of the hue. But the problem is that the color type converter I mentioned earlier that supports XAML attribute settings of color values doesn't support the HSL model. Now, whenever you find a need to set an attribute in XAML to a value indirectly through some other mechanism, think XAML markup extension. This is a general purpose mechanism. It involves a little bit of code. Generally, the code is reusable. The XAML markup extension is one of the primary ways to make code and XAML work in harmony. I have a library in this solution named Toolkit, and which can be accessed by the app. It's a PCL, so it can be used in Xamarin Forms apps. In that library is a XAML markup extension called HSL Color Extension. A XAML markup extension implements the I markup extension interface, which only involves one method named provideValue. The argument to provideValue provides additional information in some contexts. We don't need it here. The class itself defines 4 properties for HSL color specification and then creates a color value by calling color from HSLA. Now, to use custom classes in your XAML files, you need another XML namespace declaration, as shown here. Rotated text color. Here we go. You can see this at the top. You need to specify, you're using external classes, so you need to specify both the CLR namespace, the common language runtime namespace, the .NET namespace, as well as the assembly, which is the name of the DLL. If the code's in the same assembly as the XAML file, you don't need the assembly part. You can then reference something from that assembly with that XML namespace specification. And although the class is named HSL color extension, all you need is HSL color because it's recognized as a XAML markup extension. And there is all the 16 labels referencing that text color. Now again, in code you do it as a loop, but in markup, it's really not that bad. And let's see what it looks like on Android and Windows Phone. OK. Now, Xamarin Forms provides several crucial XAML markup extensions, including by far the most important one, which is binding. Binding is something you can use in code as well, but the XAML representation is often considerably easier. A binding, also called a data binding, connects 2 properties of 2 objects. so that changes in one of the properties is reflected in the other property, and perhaps vice versa. Very often, one of the properties involves data, and the other property is in the UI. But you can also connect UI elements with data bindings. Here is some XAML that does not have a data binding. Rotation event page. This is a program that's intended to allow you to interactively experiment with the rotation property. There's a label at the top that will be rotated, a slider to rotate it, and another second label to display the current value of the slider. Notice the slider is initialized for a range of 0 through 360 degrees. Now, in the XAML samples you've seen so far, there hasn't been any interaction between the XAML file and the code behind file. This particular sample demonstrates how it's done. The slider has an event handler set on its value changed event. That event handler must be implemented in the code behind file. Also, the two labels have an attribute called xName. The X prefix indicates this is an attribute intrinsic to XAML, rather than just a particular implementation. The XAML parser creates private fields in the class corresponding to these names, which means that any code in the class can access these elements. These are the two basic tools to allow the code behind file to interact with the XAML file. Anything you need to reference in code gets an xName attribute. Any event you want to capture gets an event handler in the code behind file. Here is that code behind file. The event handler does two jobs. It sets the rotation property of the first label, and it sets it to the value of the slider, and it sets the text property of the second label to a formatted string indicating the angle. So let's look at that page. And in Windows Phone? OK. And when we manipulate the slider, we see that the text rotates, and we see the display of the angle. But there's a little subtle problem. The text at the bottom isn't initialized properly. We forgot to set it to some initial value. It only kicks in when the slider starts changing. Now, whenever you see an event handler in a code behind file, you should ask yourself, how can I get rid of that event handler? Because instead of having stuff going on in both the XAML file and the code behind file, it would be better to have it all the interaction in the XAML file itself. And if code needs to be involved, and code very often needs to be involved, the code should be reusable code. Event handlers in the code behind file are intrinsically non-reusable. And that's what the binding is for. Here is that same program. Now, binding. Now the slider has a name. And the label rotation property is set to a binding markup extension. The source references the slider object. This uses xReference. This is a nested markup extension. The path references the value property of the slider. Both the rotation property and the value property of type double, which is great. The mode setting indicates two-way, which means that data binding goes both ways. Notice no quotation marks appear in the XAML markup extension. I've initialized the slider this time to -360 to 360. The second label also has a binding to the value property of slider, but the binding targets the text property. Now that we have two, we want to display a text version of the double. We're dealing with two different properties here, two different types here. We need to convert a double to a string. Fortunately, there's a special binding property for that called string format. It requires a .NET formatting string. Unfortunately, .NET formatting strings also involve curly braces, just like XAML markup extensions. But XAML parser from being confused, you can put the .NET formatting string inside single quotes, and it'll be just fine. Now, when we run this, rotation binding, we see that the label down the bottom is initialized automatically. The binding kicks in even before we do anything. We also see that the slider has been initialized to 0 in the center as courtesy of the two-way bindings. And we see that the binding actually works. And we have eliminated the stuff in the code behind file. Now, there's an event handler. There's still an event handler. But the binding itself is responsible for that event handler, and we don't have to think about it. We've also, besides eliminating something in some non-reusable code in the code behind file, we've also eliminated like a moving part in this program. Let's try another one. Switch color event. The switch property, the switch has a property named isToggled and an event named toggled. And in the code behind file, that on the toggled event handler sets a color to the first label and sets some string to the second label. You can try it out. And we can flip the switch, and the colors change, and the label changes. Let's replace that event handler with a data binding. And immediately, when we start to do this, we run into a problem. The isToggled property of the switch is a bool, but the data binding will be set on a property of type color. How do we convert a bool to a color? We just can't set it there because, as I said, XAML is a strongly typed markup language. It will not allow that. So this is another job for tiny pieces of reusable code. These pieces are called value converters. They're also informally called binding converters. These converters implement the I-value converter interface. Here is an example in my toolkit library. Bool to color converter. The I-value converter interface requires two methods named convert and convert back. This particular value converter also defines two properties on its own named color, of type color, named true color and false color. And the convert method casts the incoming value to a bool, chooses one of these two properties. Convert back method does the opposite, but the convert back is not used in the code, in what I'm using it for. Also have a bool to string converter, which is very similar. The convert method simply chooses between two strings based on the bool input. Now, in the XAML file, switch color binding page, it's easiest to instantiate these binding converters in the resources dictionary. This allows them to be shared among multiple bindings in the XAML file. The bindings themselves then reference the converters, so that when the bool value comes from the switch and is used to set the text color or the text property of these two labels, it goes through the converter, which performs the conversion. And we see that, again, the second label is now initialized, and the binding works. Now, you might say, what's the point? We got rid of the event handler, but we had to replace it with some other code. This is true, but the code that we replaced it with is reusable. That's why we put it in a library. Event handlers in the code behind file are not reusable. It's also possible to do this job and similar job entirely without data bindings, entirely without binding converters. hence without any code at all. This involves something called a trigger. Now, triggers come in several varieties, but basically, triggers are a generalized way to respond to an event or a property change in a XAML file by changing some other property or running a little code. Here is the same program. Switch color triggers. Using a trigger. Here's how it works. Here's again, we have the switch here named switch. Here's the first label. We first set the text color to like a default property of red. The text property of the label at the bottom is set to the color is red. All the visual elements have a collection property of type triggers, and you can add various trigger objects to that collection. In this case, it's a data trigger. The data trigger contains a binding that references the property of some other object, which here is the isToggled property of the switch. If that property becomes a particular value, in this case true, then you can have one or more setter objects, just like in a style, and these setter objects kick in. And this setter changes the color to blue, and the one on the bottom changes the text to this color is blue. And now when we run this version of the program, switch color triggers, and it works the same way. Now, triggers are great for handling those common, annoying user interface jobs that you just hate to waste code on. For example, it's not so common in mobile apps, but it used to be common on desktop apps that you'd have a button that should only be enabled if there's some text in an entry field, like so. So that button is disabled right now, but if we type a file name, it suddenly gets disabled. And when we eliminate that, it gets disabled again. Here's the XAML. The data trigger on the button contains a binding to the text.false. There's just a little trick here. By default, the initial text property of an entry is now, you may know that there is a rather, it's trying to connect to the internet, I think. You may notice that Xamarin Forms has a cool animation library, but it's all code-based. There's nothing in there's no animation facility in XAML. Oh, man, come on. Windows 10, what are you going to do? So what I wrote were little trigger actions called scale action, which just wraps a scale to property, and rotate action, which wraps the rotate to property. And I can use these in various, use these with triggers. That too, wow. Yeah. All right, okay. You can also put triggers in styles. So when the focused event of the event trigger, when the focused event becomes true, the scale action makes it bigger, and when it becomes false, unfocused, when the focused event is fired, the scale action makes the entry bigger, is fired, it brings it to the back to the same size. So what this looks like is here. When we need to type something, when we click each of the entry fields, it just gets a little bigger. And this is done almost entirely in XAML with a little code for support. I ask how we harmonize code and markup to avoid repetitive markup and use reusable code. Nope. Markup can't do it alone. We always need a little code to help out. But the objective is to make the code reusable. Code in a code behind file is simply not reusable. You should try to replace initialization and event handlers in the code behind with more reusable classes. These classes include type converter derivatives to help make XAML a strongly typed markup language, markup extensions, binding converters. You saw a little bit of triggers. There's all behaviors which can attach a whole bunch of code to particular elements. Whenever you get the code out of the code behind file, give yourself a little pat on the back. The model view model architecture, big subject in itself. I think there may be 1-2 talks about it. A great way to separate the user interface from the underlying business object. Now, MVVM was designed with XAML and data binding in mind. The back end of this architecture, the model, can be as grungy as it needs to be. The model is like the developers in the back room who sleep on cots and live on pizza. But the view model needs to be dressed up a little. The view model is like the marketing guy who wears a suit because he interacts with the public. And the public, in this tortured simile, is the user interface itself, the view. And the view and the view model generally interact with data bindings. The view model should not be designed for a particular user interface, but it needs to be designed for data bindings with XAML. This involves implementing iNotify property change, and for collections, to implement iNotify collection change, which in a practical sense means using observable collection. You might be making custom classes for layout or custom views. To instantiate these classes in XAML, you'll want a public parameterless constructor. You'll want to back your properties with bindable property objects. This allows the properties to be targets of styles and data bindings. To learn more, visit the Xamarin website. Check out our documentation. Check out Xamarin University. I work on the docs team. I work with a great bunch of dedicated people on this team. And Xamarin's commitment to documentation comes from the top. Also, for Xamarin Forms, remember to RTFB, read the Forms book. It contains much more information than can fit in a 45-minute talk. Most of the code you saw here is either identical to or derived from samples shown in the book, and there's lots more stuff. If you did not get a free copy of the book, you can pick up a free copy at the Get Your Xamarin Gear booth. Did I mention it's free? The Xamarin Gear booth near registration. They still have copies if you haven't yet gotten one. Thank you very much.